I'm going to do two examples of finding the derivative. We're going to go back to using the product rule, and I want to find this derivative so that we can motivate the next section. So my function is a product of 3x squared plus 8 times another 3x squared plus 8. So it's 3x squared plus 8 multiplied times itself. And we're going to find a derivative using the product rule. If I take a derivative using the product rule, the derivative of f is going to be take the derivative of the first piece, that is going to be 6x, multiply it times the normal second piece, that is going to be 3x squared plus 8, plus the normal first piece, that's 3x squared plus 8, multiplied times the derivative of the second piece, that's 3x, or that's 6x, excuse me. So that's the derivative. Now what I am going to do is I'm going to rewrite that. And the way I'm going to rewrite that is I'm going to take and say, since both components have a 6x squared, 6x, and both components have a 3x squared plus 8, I'm going to sort of factor out the 3x squared plus 8 on the back side. And then on the front side, I'm going to have a 6x plus 6x, which is actually just 12x. Or in other words, 2 times 6x. So we get a 12x multiplied times 3x squared plus 8. Let me rewrite this as 2 times 6x times 3x squared plus 8. You'll notice that this 6x is the derivative of one of my expressions, or both of my expressions. And you'll also notice that 3x squared plus 8 squared was really my original function. So notice that I have a function or an expression inside of a mathematical operation of squaring. And what happened is that expression had its exponent reduced by 1. And then that 2 came out front. And it happened to multiply the derivative of the inside function. So it's almost like I took the 2 out front, I left the 3x squared plus 8 alone, and lowered the exponent by 1. And then out front, I had to multiply times the derivative of the inside expression, namely 6x. Now, that doesn't just happen in this one. What we're getting at is that the product rule can lead us to something else, and that something else we're going to see in the next section. Let's take another example. Example 8 is sine x times sine x. And let's find the derivative using the product rule. And let's see if I get the same type of expression that I did previously. So sine x times sine x. Let's take a derivative. Product rule would say derivative of sine is cosine of x multiplied times normal second function. The normal second function is just sine. So cosine times sine plus normal first function is sine times derivative of the second expression, that's cosine. What we get here is a derivative of g, which is 2 times cosine x sine x. Once again, we have sine x quantity squared. And how did we get this? This 2 would have come out front. 2 comes out front. Sine x gets left alone and raised to a first power. And then out front also, we have to multiply times the derivative of the sine of x. Notice we're getting a very, very similar thing to what we had before. We had something to the first, our expression to the first power, and then that was multiplied by 2 times the derivative of my expression. Expression to the first power times 2 times the derivative of the expression. And so we see we have a pattern when we have a function being squared or an expression being squared. We have this weird pattern. And we're going to see in the next section that this is just the tip of the iceberg. This is a specific idea that correlates to a more general rule, which is called the chain rule. Again, we'll see that next section.